Okay, so we are asked to use a graphing calculator to graph this function, 7 cosecant x. Okay, I think I can remember that. Double check. Oops, that's not the right one. 7 over x. Okay, there's our graph. We're trying to evaluate the limit as x approaches 0. So x equals 0 is right here, so it looks like the limit should be 0. We're supposed to show that using Hopitals Rule. Hopitals Rule is when we have indeterminate form, when we have 0 over 0 or infinity over infinity. You get the idea. We don't have that yet, but let's try to rewrite. Cosecant is the reciprocal of sine, so here is an equivalent expression. And then we can get common denominators to make it into a fraction. Multiply the top and the bottom by x. Multiply the top and the bottom by sine of x. And now we have common denominators, so now we have indeterminate, well actually I haven't checked. I think we have an indeterminate form. Yeah, the denominator is going to be 0 as x approaches 0. The numerator is going to be 0 minus 0. So we have indeterminate form. So using L'Hopital's rule, I'm just going to write limit, not write the rest of the limit notation. The derivative of the numerator is 7 minus 7 cosine x. And then the derivative of the denominator needs product rule. The first function, derivative of the first function times the second kept the same. Plus the first function times the derivative of the second. Oops, that's going to be x cosine x. And so if we were to substitute x equals 0, we would have 7 in the numerator, so we don't have indeterminate form anymore. And if we substitute 0 into the denominator, the sine of 0 is 0, and then this is 0 times 0, so that makes 0. So it's not indeterminate form right now because, oh wait a second, I'm sorry, I messed up with the numerator. Cosine of 0 is 1, so this would be 7 minus 7. We still have indeterminate form, so that means we get to use L'Hopital's rule one more time. So the derivative of 7 is 0. The derivative of negative cosine is negative sine, so the two negatives cancel. The derivative of sine is cosine. And then we need product rule again over here. So this is cosine x. And then this is going to be minus x sine x, because the derivative of cosine is negative sine. So we have 0 in the numerator, if we were to substitute x equals 0. In the denominator we have 1. Plus 1 makes 2. Oh, we don't have indeterminate form anymore. If you plug in 0 in the numerator, you get out 0 for the numerator. If you plug in 0 in the denominator, you've got 1 plus 1 minus 0. So that makes 2. So that's not indeterminate form. We know what that limit is. 0 divided by 2, that's going to be 0. So using L'Hopital's rule, we show that that limit is 0 that we saw graphically.